Now, we will be talking a little bit about the sums and products of roots, which is section 6.5 in the textbook. Now, for some of us, we know last week we talked about basically completing the square and the quadratic formula, which are all wonderful and painful, right? But now with this sum and product of roots, what we'll be able to do is work on sometimes a little bit of an easier method to perhaps either find roots and use it to go backwards, mostly to find equations, and sometimes for us easily to factor equations as well. Now, we have two objectives from this section. So, our first objective is to find the sum and product of quadratic equations. The second is to fit the model. To find a quadratic equation to fit a model. Everybody got it? Mm-hmm. If you need, you can go back and pause this lecture and you can get back to this. Okay. Recall from last section the quadratic formula. Recall that we talked about a quadratic equation, which any quadratic equation can be rewritten as ax squared plus bx plus c is equal to 0. And recall that from the quadratic equation, minus b plus square root of b squared minus 4ac all over twice a. We had two roots to the equation. Okay. Recall that, right? The little 2 means I have two answers. We have two roots, which of course are the solution to the equation. Now, from that, together, which is what a sum is. And of course we can multiply them, which is what the product is. So, if I add the two together, something like, I will get a formula. Like that. We add them together. Now, if I add these together, then since one is positive and one is negative, the square roots will cancel each other, and they're exactly the same. And we have, of course, negative b and negative b, which will get twice negative b. Okay. From here, the 2's cancel, so we get the sum of roots is negative b over a. Something very important. So when you add the two together, you get the middle term and the first term, okay, of a quadratic equation, or the middle coefficient and the leading coefficient. If another way you want to put it, I'll write it down on the new page for you. Okay. Okay. So when we add the roots together, we get the fraction or ratio of the middle coefficient over the leading coefficient of a quadratic equation. To cube it up. Okay. So x1 plus x2 equals negative b over a. We get the opposite, really, we should say, probably. We get the opposite of the middle coefficient over the leading coefficient here. Okay. So on the top, we have opposite of the middle coefficient. And then we have over the leading term, the leading coefficient. Okay? Then it's a fraction, like that. So when I can use that idea to piece together the part of the function, okay, part of the quadratic equation. Now we have one more piece that we need. We need to have products of these roots together, okay? So if I have a product, what happens? So in this situation, this is x1 multiplied by x2. Okay, that, again, using the same equation from quadratic formula, like that. On the top, we have a difference of squares. So we'll use that fact to develop this. And of course, when we multiply fractions, we just multiply across. That's 2a times 2a. Okay. Simplifying this expression, let's use a moss color for that. Okay. It becomes b squared minus parentheses b squared minus 4ac all over 4a squared, like that. Then we'd use the distributive property for that. So, distributing it, we get b squared minus b squared plus 4ac over 4a squared. That's 0. It's all equal. And so we end up with the product of the roots ends up being 4ac over 4a squared. 4's kill each other, and so does the 1a, so we end up with c divided by a. I'll put that on a new page. So we end up with x1 times x2 is equal to c divided by a, which, so when we multiply, we get the fraction of the constant term to the leading coefficient. So that helps us to develop the entire equation without having to worry about finding everything necessarily. Okay. So it looks like this. C, the constant term, over A, which is the leading coefficient. Okay. Everybody got it so far? Okay, good. Like the thumbs up I'm seeing? Right, good. Now, let's do an example of this. Okay. Find a quadratic equation negative 1/3 and 2/5. Okay. So instead of having to go about and use FOIL and do all that kind of work, we're going to do it a little bit. We're going to use a little bit of a different method here. Okay. The first thing, we need to find the sum. Okay. So we need to find that sum. So to do that, obviously we add them together. And since we're adding fractions, we need to have common denominator. And so we'll do it the lazy way. Multiply this way, and that way. Okay. To all that work, that's -5 plus 6 over 15, which is 1 over 15. Okay. And so recall with the sum, it's going to be -b divided by a is equal to 1 over 15. And so from this, I already know that b will equal -1. And I already know that a will equal 15. Okay. And now we need the last part of the puzzle, which will be the constant term, which we need the product of that for. Okay. Does everybody have that? Thumbs up? Okay. Awesome. Let's go back. And of course, the second piece is we need to find so x1 times x2 is going to -1/3 times 2/5, which will be -2 over 15. This is the leading coefficient. And this is our middle term, our constant term, sorry. Okay. So our c over a is -2 over 15. C is equal to -2. And a is equal to 15. And of course, b is equal to -1 from earlier. Okay. And so, the quadratic equation, after all this, If you don't mind if I erase this all. Okay. And so the quadratic equation ends up being 15x squared minus x minus 2 is equal to 0. That ends up being our equation. And we can check this by factoring it. 5, 3, 1, and 2. Get -2, -1, so the negative, that would be positive. Five minus 1, 5x minus 2, x plus 3. Oops, sorry. 3x plus 1. This being 3x plus 1. There we go. So we end up with the answer that we were supposed to have. Okay. Very good. Everybody understand? Thumbs up? Хорошо. Very good, everybody. So, now, what I want you to do is try one on your own, and then I will get back to you in a couple of seconds with the answer to the problem. So, let's go ahead and clear this. Okay. This is your self-done example. We've gone through this. Example 2. Quadratic equation with roots 7 over 5. I don't know. 11 over 15. Something like that. Okay. So, I'll pause it, and then we'll get back with the answer.